Power of a lens. Power of a lens, which we have defined it as what terminal? Reciprocal of focal length. Reciprocal of focal length is called as a power of a lens. Power which is equal to 1 by f. And if it is in meters, 1 by f. If it is centimeters, then it is 100 by f. And this SI unit is diopter.
Yes, sir.
So this means, and power, if it is some other medium is given, then power is equal to mu by f. Mu is a refractive index of a medium. And so for the convex lens, and so focal length is positive. Focal length is positive means power is also positive. Right. And for concave lens, focal length is negative, that's why power is negative.
Yes.
Okay. Yeah. Next. Copy this thing here. Understood?
Understood, sir.
Now let's talk about the next one. Lens displacement method.
Yes, sir.
And what the lens displacement method means, what terminal? So consider this is we have one convex lens is there. And here we have placed some screen is placed here. This is the screen. Screen is placed. And here see the principal axis at this location. So let us say some object is located. Here some object is located. Object is located. Right. Now, so the screen, what they used to say here, lens displacement method means. Lens displacement method. Now, when we place the object now here, there is image will be formed on the screen. We have one image will formed on the screen. Okay. So we have that one image will be there, will be formed on the screen. Okay. Now, this is an object distance as usual, which will be equal to u, and distance between the object and the screen, this distance which I am calling it as a capital D.
Yes, sir.
Capital D. Now, so this is the one position, first position I am calling. Now, if the distance D, if the distance between the object and the screen, if it is equal to, if focal length of the lens is here, then it is 4 times, we can say that it is greater than or equal to 4f. If it is greater than or equal to 4f, then lens has a 2 positions. Lens has a 2 position, so that image will be formed on the same screen.
Yes, sir.
So means the lens, this is one position. So here, even if we move, let us say that my lens I have moved to some other location. First position to second. This is the second position of lens. This is the second position of lens. And the distance between the 2 positions of lens, which I am calling it as a small d, where capital D is the distance between object and the screen. Small d is the distance between the two positions of the lens. If this capital D is more greater than or equal to 4f, then we have two images are formed on the screen. Then the lens has a two positions. Lens has a two positions, so that image will be formed on the screen. Okay, so this is called as a lens displacement method. In this lens displacement method, what are the things you need to highlight now here? First thing here, first thing, the condition is, these are the things you need to remember. First thing is, what, tell me now? Lens has a, if capital D is greater than or equal to 4f, then what happens now here? Lens has two positions.
Yes, sir.
Two positions. So that real images formed on screen. And so in this case, there are two images will be formed. Here in this case, how many images are? Two images. One is a magnified image, other one is a diminished image.
Yes, sir.
Two images are formed on the screen.
Yes, sir.
Two images are formed. And one is magnified image, other one is diminished image. Next, here. So from this we can get the focal length of the lens we can get, that is focal length, which is equal to d square minus small d square by 4d. The focal length of a lens is this much. D square minus small d square by 4d. Okay.
Okay, sir.
And there is another formula for the focal length, that is given as small d by m1 minus m2. Small d by m1 minus m2. M1 is what, tell me now here? M1, M2 are the magnifications. So here, one is a magnified image, other one is a diminished image. Those magnifications are there. And so where this is the product of this m1 into m2, which will be equal to 1. If it is 1 is a magnified, jitna magnify hoga, second one is utna diminished hoga.
Yes.
Yeah, if one is magnified by 10 times, other one is diminished by
10 times.
10 times. Right. Next one. And another thing we need to here remember, this thing is another important thing here. Well, in this case, now this is height of this object. Height of this object, which is equal to square root of hi1 into hi2. What the hi1, hi2s are the?
Sir, height of first image is
second images. These are the things you need to remember for the lens displacement method. The first thing is what, tell me now? If the distance between the object and the screen is greater than or equal to 4f, then we have a two positions are possible. And
yes,
you can form the two images. One is magnified image, other one is diminished image. And that m1 into m2 will be equal to 1. And we
Yes,
have
sir.
two formulas to find the focal length. If you
Yes,
know
sir.
capital D, small d, we use this formula. If you know magnifications, we use this formula.
Yes, sir.
Right?
Yes, sir.
Yeah, next one we'll see this as lens with different media on either side. Generally, for the lens, what we used to consider left and right will consider single medium only. If we
Yes,
have
sir.
different mediums is there, in those cases, what should be done here? Look at now. If the lens has a different mediums are there.
Yes, sir.
So consider we have this is my convex lens. And if I call this here is my object and here the image is formed. Let us consider the radius of curvature. Radius of curvature of this one. So which is equal to R1. The radius of curvature of this one is R2. And the refractive index of this my lens is a mu. Okay.
Yes, sir.
And this left side will have a refractive index. I am calling it as mu A. The right side refractive index is mu B.
Yes, sir.
Now, in these cases, how the relation of the lens, so the lens maker's formula, how it was modified, we need to see. In those
Yes, sir.
cases, object distance, image distance, to find the lens formula, it is modified as like this, and which is equal to, and this is image distance now, and which is V, and this is object distance, which is U, and this is mu B by V minus mu A by U object distance, and which is equal to mu minus mu A by R1. This one mu, this minus this minus this by R1 plus mu B minus mu by R2. Okay, this is
Okay.
the lens formula. If the left and right we have a different mediums are there, this formula we need to apply.
Yes, sir.
Okay.
Okay, sir. Sir, sir, like, but if this half is in another medium, so like it will behave different in a sense.
This half of the lens you mean to say?
Yes, sir. Half of the lens.
Half of the lens now. Look at now here. Even though half of the lens is different medium, so this means lens medium refractive index will consider.
Sir?
Lens refractive index only. So here this part is, so you mean to say that, so this one here you need to say this is mu1, this is mu2. The lens is there like this, you want to say.
Yes, sir. Yes. Like for example, nu1 is in air, so nu2 is in some water. Like
It
so
may be possible.
This half in water, like different behavior will see.
So that's why only we need to use this thing, these relations, and we need to find the focal length of that lens will be calculated now.
So like 4 mediums will be there.
No. So here, so even though, so this mean mu1 and this refractive index mu na, we need to see
Yes,
this
sir.
thing as no, even this medium. So we need to talk about this lens we are talking now on its surface. Lens refractive index is mu only na.
Yes, sir.
That we have to consider.
Yes, sir. I thought like if nu only it will like change in different medium.
So,
Like in air one, it will be like one method, and for water it will be like another.
okay. Refractive index of the lens only will consider.
So like same it will behave, sir, in any medium?
Yeah, yes, even though in this manner it will behave. We need to
Yes,
see,
sir.
we need to consider about what tell me now here, left side, right side, and lens refractive index will be effect.
Okay.
Yeah, take this problem.
Yes.
Hmm. So what they're saying here, the diagram shows the concavo-convex lens. What is the condition of refractive indices so that lens is diverging? Diverging lens means what lens?
Sir, it is concave lens, sir.
Yes, so concave lens. Concave lens is also called as a diverging lens, first of all. So for the diverging lens, concave lens, and what the focal length is a positive or negative?
Sir, it will be negative, sir.
Yeah, so that is negative, that is less than 0. Okay.
Okay.
Okay, now you can tell me now here in this case. Now, so here left side, this medium given as mu1, this medium is mu3, and lens refractive index is given as mu2. Now in this case, previous formula we need to apply.
Yes, sir.
Okay. Yeah, tell me now here. So the light rays are coming from infant parallel light rays. How these light rays are parallel to principal axis now? If the light rays are
Yes, sir.
parallel to principal axis, that means the light rays are coming from infinite distance. That means object is at infinite distance.
Yes, sir.
Okay. So this is object is at infinite distance. Yes, with the object is infinite distance. Now you tell me now here, we use a lens formula 1 by f, which is equal to what, tell me now? 1 by v minus 1 by u now.
Yes, sir.
V is the object now here. Object is infinite distance. Sorry, object is infinite distance. If it is mu value infinity, so that is 1 by infinity is 0 now.
Yes, sir.
Then we'll come it as what, tell me now? 1 by f is equal to 1 by v, right?
Yes, sir.
From this, what I can say now here, f is equal to v only now.
Yes, sir.
F is equal to v only. Okay, this thing fine. Now we need to find the f, that is nothing but v value we need to find. Since they are saying this as a diverging lens, and we need to equate the focal length is less than 0.
Yes, sir.
Yeah, now you tell me
Sir,
the
one small doubt.
hmm.
Sir, but like if we take concave or convex, the second name will consider, sir, generally.
Concave or convex lens.
So in concave or convex, convex will be like considered, no, sir, like second name.
Second name.
Like
No,
yesterday we
no.
have discussed.
So second name is considered, but those will be depends upon what, tell me now. The mediums also will depends.
Okay. Yes, sir.
Those values will depends on the mediums also. So to become like it as a concave lens, we need to find the what will the condition of mu2 we need to get.
Okay. Yes, sir.
Okay, so let's now focus now here in this case. Tell me now here what we
Okay.
can do. We'll write the equation now
Yes, sir.
and tell me the equation of just now we have seen now. And so here, yeah, this radius of curvature is given 2r. This radius of curvature is given r.
Yes, sir.
And this medium refractive index mu1. This is mu2. This is mu2, mu3, mu2 given. Okay.
Okay.
Tell me the equation now. What will write now here? This is the object image. Where the image is now here. Second medium now here somewhere.
Yes, sir. Second medium, sir.
So that means what we can say now. This is mu3 by image, which is equal to v.
Yes, sir.
Minus what, tell me now, mu1 by object is at infinite distance now.
Yes, sir. Infinite distance.
Which is equal to what we wrote now here. This is mu2
mu2
minus mu1
mu1.
by R1. R1 is how much, you tell me now? R1.
R only again.
R1 is how much?
Okay. Minus 2R.
Yes, that is minus 2R. Okay.
Yes, sir.
Plus, next. Tell me.
So next, mu2 minus mu3.
mu3
Sorry. mu3 minus mu1.
mu2
So mu2 by
what, tell me
plus
now?
R.
R2. So this is, and which direction is open here? Left or right?
Left side open.
Left side open means what? Positive or negative?
Okay, negative, sir. Negative.
That is what, tell you now? Minus R.
Minus R.
Yeah, simplify this thing here. We can say this is mu3 by V, which is equal to, minus is there, so then minus will go to numerator. Then we can write as what, tell me now? Mu1 minus mu2 by 2R we can write now.
Yes, sir.
Is also minus, plus what I can say now, this is
mu2
minus
mu3.
mu3 by R.
R. Yes, sir.
Yeah, now simplify this thing here, take LCM and simplify it now.
One minute.
So we have, this is mu3 by V, and which is equal to 2R is LCM.
Yes, sir.
So what will get you, tell me now? This is mu1 minus mu2 plus 2 mu2 minus 2 mu3. Check it.
Yes, sir.
So then we'll come it as mu3 by V, which is equal to how much now? Cancellations. This is mu1 plus 2 mu2 minus 2 mu3 by 2R na.
Yes, sir.
This one we got it. So from this, okay, from
Sir.
this,
Sir, here, no, mu2 will be positive, sir.
okay, plus
mu2 minus 2 mu3 minus mu1.
Okay, this is mu2 minus, okay, 2 not 2 mu2. Okay, so then this value, okay, this value will come it as mu2 only na, mu2 minus 2 mu3.
Yes,
Isn't it?
minus 2 mu1.
Okay, so from this, if I take a reciprocal, V by mu3, which will be equal to 2R by, that is mu1 plus mu2 minus 2 mu3 na. So
Sir,
this
mu1 also negative one.
mu1 negative. Why negative? mu1 positive one, yeah.
Okay. Yes,
Minus, this
mu1
minus is
positive one.
interchanged. Okay.
Yes, sir. Positive one. Yes.
So this means from this, V is equal to what, tell me now? This is 2R into mu3 by what, tell me now? mu1 plus mu2 minus 2 mu3 na. This is what, tell me now?
Yes, sir.
V, as we have seen, V is equal to F only na.
Yes, sir.
And V is equal to F only. So from this, focal length is how much, you tell me now? F is equal to V only. So that is nothing but 2R mu3 by, this is mu1 plus mu2 minus 2 mu3 na.
Yes, sir.
Now, so then what they are saying, this is what type of lens has to be?
Sir, this has to be diverging lens.
Diverging lens means focal length is positive or negative?
Yes, sir. Focal length negative, sir.
No, divergent lens means concave. Now, focal length must be negative. So here, so this means F must be less than 0 na. For that, so this numerator cannot be negative. only denominator has to be negative, na?
Yes, sir.
So that means what we can say, this is
Yes, sir.
mu1 plus mu2 minus 2 mu3. This is less than 0. Then we can say this as
Yes, sir.
mu1 plus mu2 is less than 2 mu3. Okay.
Sir,
Huh.
so like here, numerator is saying it can't be negative.
What?
Part one schedule.
What?
Like
Nu-
it might, numerator like
numerator R
cannot
is
be
what,
negative.
radius, na? Radius
But
cannot
like
be.
mu3,
mu3 is a refractive index is always positive quantity. Always greater than 1.
yes, sir.
Okay, refractive index is always positive quantity. It can never be negative. Greater than 1.
Yes, sir.
Minimum value of refractive index is 1.
Okay, sir. Okay.
It may be greater than 1, but never be less than 1 also. Even it can never be negative also.
Yes, sir.
Okay.
Okay, sir.
The concept will do. We don't have time. Yes, next we'll do combination of lenses. Yes, combination of lenses. So that means, let us say we have the two lenses are placed like this. Now,
Yes, sir.
this focal length of this lens, which I am calling this as a f1, this focal length of this lens is f2, and these two lenses are separated by a distance of d. Now we need to find the equivalent focal length or effective focal length we need to get. The equivalent focal length of this combination of lenses, which will be equal to equivalent focal length of this combination, which will be equal to 1 by f equivalent is equal to 1 by f1 plus 1 by f2 minus d by f1 into f2. This is the equivalent focal. Whether d is the distance between the two lenses. And same thing here, if I want this as a power, so power is what, tell me now here? So 1 by f is a power. So this means equivalent power, which will be equal to P1 plus P2 minus D into P1 into P2. This is the power. Okay.
Yes, sir.
Now what the D is the
Distance between two lenses.
yes. Now let us say the distance between two lenses is 0. Then what happens now? Yes. If D equal to 0, that means then what I will get the equivalent focal length now, which will come
1
to
by
be
f1 plus 1 by f2.
1 by f1 plus 1 by f2. Okay. If the distance between them is 0, in those cases, it should be like this. Okay.
Yes, sir.
Now what is the power now? Equivalent power?
Sir, P equal to P1 plus P2 minus
D
like
value
0.
zero
P1
na.
plus P2
Yeah,
is
so
plus.
then the equivalent power will becomes what, tell me now? So that is power, equivalent power is simply P1 plus P2. Okay. And
Okay.
so here, after finding the equivalent focal length, then we can decide what type of nature of the circuit it is. If it is the equivalent focal length is a positive, then what I can say, that length is a, if the equivalent focal length
Convex
is
lens.
positive, then it is a convex, nature is convex. If the equivalent focal
Yes,
length is negative, then we can call it as a concave lens. Okay?
Yes, sir.
Yes. If it is some cases, equivalent focal length 0 also can happen.
Yes, sir.
In that case, so it is not a neither convex nor concave. So it is simply like a transparent plate. So, and you might be used now here. So some fellows will use it generally. They don't have any sight, but still they will use the specs they use, you know. In those
Sir,
cases, so here, so this one, the lenses should not have any power. Zero power lenses. Have you heard zero power lenses?
yes, sir. Yes, sir.
It doesn't have a no side. Still no side. Some fellows will wear the specs they will wear now.
Yes, sir.
Those
Yes.
fellows will have a, so here it doesn't have any power.
Yes, sir.
Yeah, so that is a transparent plate. It is a
Yes, sir.
neither convex nor concave.
Yes, sir.
And some cases they will place the two lenses in a some medium they will place. If they place some in a medium, in those cases equivalent focal length is, means the two lenses, this focal length is f1 and this focal length is f2, and these two distance between them is d, the medium between them is mu. Okay, in those cases the equivalent focal length will becomes as 1 by f equivalent, which will be equal to 1 by f1 plus 1 by f2 minus d by mu into 1 by f1 into f2. Okay, earlier simply d by f1 f2 na, d by mu will come if the
Yes, sir.
medium between them is some medium is they placed,
Yes, sir.
right?
Yes, sir. 1 minute.
Hmm.
Okay, sir.
Yeah, take this problem. Three lenses in contact. Contact means there is no gap between them. Have a combined focal length of 12 centimeters. When the third lens is removed, the combined focal length is 60 by 7. The third lens is uh, three lenses are in contact. That means there is no gap between the lenses. So equivalent focal length, which will be equal to what we can say 1 by f1 plus 1 by f2 minus d, sorry, so 3 are there now, plus what we can say now 1 by f3, and these are in contact, that's why there is no gap between them. Okay, this value equivalent focal length is how much given? 12 is given now. That is
Yes, sir.
nothing but what we can say now 1 by 12. Now they are saying it as what are the third lens is removed. Third lens is removed. F3 is removed. Then what we have, tell me now. That is 1 by F1 plus 1 by F2 only now. So that is equal to equivalent focal
Yes, sir.
length will come. Now in this case, when third lens is removed, the equivalent focal length is given as how much now? 60 by 7. Okay, so that
Yes, sir.
means reciprocal means 7 by 16.
Yes, sir.
Now, so this is equation 1, this is the second equation. Equation 1 minus equation 2, I will do first equation minus second equation.
Yes, sir.
Okay, then what I will get now here, 1 by F3 will come now. F1, 1 by F1, 1 by F2 will get cancelled. That is what will be now?
Yes.
1 by 12 minus what will be now? 7 by 60.
Yes, sir.
That is 1 by F3, which is equal to LCM. You can see now. How much the LCM is? 60 is LCM. So this is 5 minus 7 will come it as what will be now? Minus 2 by 60. So that means how much this F3 will come, you tell me now? Minus 13. So that means what I can say, this lens is now convex or concave?
Sir, it is concave lens.
Focal length negative na concave. So that means what's the option now?
Sir, it is third option. Diverging lens.
So diverging lens of focal length 30 centimeters. Okay.
Okay.
Next. Arrange the following combinations in increasing order of focal length. Increasing order of focal length. We need to find the each focal length we need to find. Yes. Now here first case. Now they given the two lenses having focal length is how much, you tell me now? So F1 is given as 20 and F2 also given 30 only na. F1, F2 given 30.
Yes, sir.
Next, and they are saying that these two are in contact. So that means D is how much now? Distance between them is 0. Next, find the focal length of this combination now. And what's
Yes,
the
sir.
focal length of this combination? That is 1 by F equivalent, which will be equal to 1 by F1 plus 1 by F2, since D value is 0. Then we can write this as 1 by 20 plus 1 by 30 now. Now, so simplify.
Yes, sir.
Take LCM now here. This is 1 by F equivalent, which will come to be a. If we multiply, so that is 50 by 20 into 30 will
Yes,
come
sir.
now. Now
Yes, sir.
calculations. So tell me now here this value 5 6 now here. So then from this how much the equivalent focal length will come, tell me now, which will be equal to 12, isn't it? Second case, they given two convex lens of focal length 20 and 10. So that means they given us F1 value given 20 and F2 they given as 10 and D value they given 0. Yeah, tell me in this case what will be the equivalent focal length now? That is equal to 1 by 20 plus 1 by 10. So we can say 20 only LCM 1 plus 2. So that is 3 by 20. So that means F equivalent will come to be how much now? 20 by 3. Okay. Next, third case, two convex lenses focal length 25, but separation between them is given 5 centimeters now. So in this case, tell me now here C case, they given F1 is equal to 25. F2 is also given as 25 only now. Okay. Yes, next, and D given now. How much the D value given now? 5 centimeters. Now, in this case, equivalent focal length formula is what, tell me now? That is 1 by F1 plus 1 by F2 minus D by F1 into F2 now. Now, you can find the equivalent focal length. It will be a 1 by 25 plus 1 by 25 minus D value 5 by 25 into 25 and simplify and get it. So this value will come it as 2 by 25 minus how much now? 5 5s. That is 1 by 125. Yes, sir. So we'll come it as 125 is LCM. Now it will come to be what element of 5 into 2, 10. 10 minus 1. This is 1 by F equivalent. So that is from this F equivalent is how much you tell me now? 125 by 9. Isn't it? So now you need to see which is greater value. So this value 12 here, this value it is how much now? I think so 6.66 now. Yes, sir. Next, this value is how much will come? It is 9. If it is nearly 10, it will be 12.5. This value 12. Yeah, so this is more now. First we have a C, next we have a A, next we have a B. B is least. This value more than 12.5 now. Yes, sir. So that is C, A, B. So this is fourth option. Yes, sir. Fourth option. Yes. Like this, we need to do it. Okay. Okay. Fine.